Hello everyone, my name is Tomas Ortega and welcome to the Data Science Workflow Manager project for Spring 2019. My team member is Serge Metellus, the product owners for this project are Steven Luis and Miguel Alonso, and the professor is Masoud Sajjadi. First, let's take a look at the problem statement. The problem that we notice is that the airline industry currently does not have the capabilities to fully utilize the large amounts of data that are generated every day to enhance customer experience, increase the efficiency of operations, or make better data-driven decisions. Following the latest data science tools and techniques, we can leverage valuable insight from airline data. In this slide, we can see the data science workflow. We can see that it has several steps for data collection, data validation, data exploration, feature selection, the plugin architecture, and the interactive dashboard. For this first iteration of the project, we decided to focus on the last three steps of this workflow. We can see that in feature selection we have two parts. The dimensionality reduction, which we didn't have time to address, and the feature importance, which is part of the visualizations and is included in the dashboard under the models that can have feature importance. After that, we have the plugin architecture. We can see that in the plugin architecture we have three main components: the integration of custom models, the train and test validation method, and the baseline modeling. Then we have the interactive dashboard, which was our main focus on the first half of this semester. In the dashboard we have several visualizations such as the CPI visualization, the oil price visualization, and the predictive models. In future versions of the project, we hope that they could implement methods for data collection, data validation, and data exploration. Next, we have the user stories. For this project, we decided to divide the user stories into groups. Here we have the user stories that belong to the user interface epic. These user stories deal with the different components required for achieving an interactive dashboard, such as dragging points around, resetting the graphs, changing the range of the x-axis or the y-axis, and change the column layout. Next, we have the epic for implement an architecture for custom plugins. In this epic, we created classes that developers working on a data science project could use to improve their workflow and create new models in an easy and straightforward manner. Here, we have user stories such as the model wrapper, which was the main part of the plugin architecture. For this, we implemented several classes that are going to be used to create machine learning models that can be used in the visualization module so that the user can visualize and interact with the data from the machine learning models. Next, we have user stories such as the visualization wrapper, which deals with the distributions such as frequency distribution and probability distributions. The retrained model on point movements will deal with the interactivity of graphs in the predictive model section, and we have other stories for the different models. We also completed user stories for the data processing and pre-processing steps of the workflow manager. The goal for this user story was to automatically clean and pre-process the data so that the models and the visualization components could have access to that data and consume it without the need of pre-processing it again. Now let's talk about the requirements. First, let's see the use cases. Here we have a use case diagram for the entire project. We can see that we have use cases for loading models, initializing models, feeding the models. We also have get feature importance for the models that deal with multivariate analysis, such as the random forest model and the vector autoregression model. We also have other use cases for changing the value of the points, selecting the range for dates in the visualizations, and selecting distributions from a drop-down menu. Now let's take a look at the sequence diagrams. First, we have a sequence diagram for moving multiple data points. In the diagram, we can see that first the end user sends a message to the dashboard that he wants to select one or several data points in this case. After that, the dashboard sends a message to the controller saying that a click event has happened. This will trigger a function that will calculate the information needed for the slider. After that, this will enable the slider in the dashboard. Then we have two options, either the button for the training is enabled or it is disabled. If it is enabled, then when the user moves the slider, he can move it to the specific value that he desires and then let go so that the controller can access the new value that the user has set and store it for future reference. Then the controller retrains the model. After that, it will store the prediction that the model will make and hold after that. After that is done, the controller then retrieves the data for the training and the predictions so that they can be visualized in the dashboard. The controller will update the figure and it will render the new data in the browser. If the train button is disabled, then the flow of events will be really similar, except that the model will be trained every time the user moves a point. In this sequence diagram, we can see that the developer can set hyperparameters for the classes that inherit from the WFMG procedure class. The developer can also call the procedure function, and this function will return data that will be used in the visualization module. Here we have another sequence diagram. This one is for the dashboard and the user interface. This one is pretty straightforward. Here the user can launch the browser, then request the home page, and the server will deliver that page. After that, the user can get into the dashboard and run the application for the dashboard. This application will access the data from the server and then return the HTML with visualizations and provide a dashboard page. One of the most challenging parts for me was working on the model wrapper user story. Here we have a sequence diagram for it. We can see that the developer can initialize a model with certain parameters. He can also fit the model so that the predictions made by that model will be accurate, and then he can call predict data to get the predictions. He could also get and set hyperparameters or save the model to a pickle file and store it on disk. The workflow management system was designed using the model view controller architecture. The model component corresponds to all the data related logic that the user works with. All data used in the visualizations are either processed in the model or processed elsewhere and imported in the model. The view component is used for all the UI logic of the application. It allows the end user to see visualizations of the model and different data distributions. The controllers act as an interface between model and view components to process all the logic and incoming requests, manipulate data using model components, and interact with the views to render the final output. The controller receives the input, it validates the input, and then performs the operation that modifies the state of the data model. Here we can see that we use the Plotly framework for the visualizations. We use scikit-learn for the machine learning models. We also use pandas for data processing and pre-processing, and Flask as the main web framework. We use the Visual Studio Enterprise as the IDE. We use Flask as the microweb framework. We use Dash with Plotly for the user interface because it allowed us to create interactive visualizations. We use HTML and CSS along with JavaScript for the front-end programming. We also use Heroku for deployment and Redis as a cache to store the results of computations, such as the training for the models, and store the changes that the user can make to each graph. We also use Bootstrap to add style to the pages. We use Bitbucket for the repository and the version control. We use Selenium to automate part of the testing process, and SciPy as an ecosystem to process CSV files and create a plugin architecture for machine learning models. Here we can see a minimal class diagram. In this diagram we can see that we have classes for the plugin architecture. We have the output stream handler and the input stream handler, which are used by every class that inherits from the WFMG module-based class. We also see that we have several files for the database, and that the dashboard controller has access to the view and to the plugins. Now let me show you the current state of the system. Here we can see the front page of the web application. We have the title, the product description. If we go into a dashboard, we can see the different graphs. First we have the predictive models. Here we have ARIMA. This is the vector autoregression model, and this is the random forest. We can go into each one of them and interact with the graphs by selecting a group of points or a single point, and then using the slider to move. We can use the slider to move the points around and change the Y value for each point. If we go to the vector autoregression model, we can do the same, and in the random forest model we can do that as well. In each of these models you can click train at any moment, and the model will be trained with the data that is shown right here. We can do the same with the vector autoregression model and with the ARIMA model. At any point we could also click the reset button, and the graph will reset to its original state. If we scroll down, we can see that we have the error graph for the model that is visible at the moment. If we have the random forest model, we can see the future importance graph and the error graph. If we keep going down, we can see that we have the distributions, so we can click on any of these graphs and the distribution will change, the graph will change. We have several graphs, one for a state of departure distribution, one for the coupon distribution, for the market share distribution, and for the fair class. Here we have the consumer price index, and here we have the crude oil price. We can use this component to change the range of the visualization and zoom into the graph. If we go to the models page, we can see information about the machine learning models that we use. In the data page, we can see information about the data sources, DB1B, which is a database from the Bureau of Transportation, and T100. In context, we can see some contact information, and that's the current state of the project. In summary, the goal for this project was to create a workflow manager that allows developers working on a data science project to introduce new models as plugins, and to allow end users to visualize and explore process data and various data distributions. I believe that in this first iteration we were able to complete these goals and create a final product that could be of use to any airline that wants to improve user experience and use data science to make better decisions. Thank you for your attention, and I hope you have enjoyed the video.